Hello further math students, and welcome to this video on the inverse matrix, which is the start of chapter 12. In chapter 11 we looked at a few different types of matrix arithmetic. We talked about matrix addition, subtraction and multiplication. Using or finding an inverse matrix is sort of a bit like doing matrix division. It's quite a complex process and there's a fair bit to understand, so let's get stuck into it. The first thing that you need to know about is this thing called the identity matrix, which you might remember from the last section. And the identity matrix is a square matrix with ones on the leading diagonal. So from top left to bottom right, every number is a one, and zeros elsewhere. All right, so these are three examples of an identity matrix, but the identity matrix can be bigger and bigger and bigger as long as it's square with ones from top left to bottom right and zeros everywhere else. The identity matrix has the property that if you were to take any matrix A and multiply by the identity matrix, you would just get the same matrix again, right? So there's a worked example here on our notes where we take a matrix A and it's just got elements 1, 2, 3, 4. It's a 2 by 2 matrix. You can see here that if we took matrix A and what we call post multiply, so multiplied by the inverse matrix after A, you could go through and do your run and dive, across the rows, down the columns, across the rows, down the columns. You're just going to end up with the same matrix again when you multiply by the identity matrix. And even if you do that multiplication the other way around, because we know that the order of multiplication can sometimes change our answer, but with the identity matrix, even if you do it the other way around, so I times A, again, going across the rows, down the columns, adding them all together, doing your thing, you're still going to end up with the same matrix A again. So the identity matrix is kind of like the matrix equivalent of the number 1, where if you times by the number 1 or you times by the identity matrix, you just get the same thing that you started with. Okay, the inverse matrix, which we call, if our original matrix was A, we would call the inverse matrix A to the power of -1. That's how we write it. The inverse of a matrix has the property that if you multiply a matrix by its own inverse, so A times A to the power of -1 or A times A inverse, whichever way around you do it, so if you did A inverse times A, you would get the identity matrix. All right, so in other words, if you multiply a matrix by its own inverse, it will equal the identity matrix. That's the definition of the inverse matrix. And it's important to understand that only square matrices can have an inverse, so any matrix that's not square will not have an inverse. But there are some square matrices that will not have inverses. So not all square matrices have inverses. All right, here's an example here. We've called it example 2, but really it's the first example, so sorry about that. We've got matrix A and its inverse are shown below, and we're being asked to show or demonstrate that if we multiply the matrix by its inverse, whichever way around we do it, we're just going to get the identity matrix. So this is just a way of almost like proving that these two things are the inverse of each other. So let's do A times A inverse first, which would be the matrix 2, 3, 3, 5 times 5, -3, -3, 2. I'm writing pretty small here because matrix multiplication will take up a fair bit of space. So this is just a good recap of going, across the rows and down the columns. So for our first element, first row, first column, we're going to do across the first row, then down the first column. So 2 times 5, which is going to give me 10, plus 3 times -3, so that actually gives me plus -9. Then if I go across to staying in the first row but the second column, I'm going 2 times -3, plus 3 times 2, and then going down to the second row, so second row, first column, 3 times 5, plus 5 times -3, so that gives me plus -15. 3 times -3 gives me -9, plus 5 times 2, which gives me 10. And you can see what's happening here. We're going to end up with the identity matrix. 10 take away 9 is 1, -6 plus 6 is 0, 15 take 15 is 0, and -9 plus 10 is 1. So we've shown that A times A inverse gives us the identity matrix. Let's do it the other way around. All right, remember in the show that question, you already know the answer. Your, job is to demonstrate how to get to that answer. So if we did that multiplication the other way around, and it's a little bit tedious, I know. So if you want to fast forward this to the end of the example, then go for it. Right, but we're going to show, using our matrix multiplication, that we should get the identity matrix again, even if we do this multiplication the other way around. So crossing down, 5 times 2 plus negative 3 times 3, so actually that gives us a takeaway 9. If I go to the second column, so first row, second column, 5 times 3 is 15, plus negative 15. Negative 3 times 2 gives me negative 6. 2 times 3 gives me 6. Negative 3 times 3 gives me a negative 9 there, plus 2 times 5, so plus 10. And what do you know, we're getting 1, 0, 0, 1 again, which is the identity matrix. So we've demonstrated that both of these multiplications are equal to, well, they're equal to each other, so I can say that is true, but they both equal the identity matrix, which is what we were required to show. Okay. Moving on to the next key idea, which is the determinant of a matrix, right? So we are working towards the inverse, but there's a few things we have to understand before we get there. The determinant of a matrix helps us to find the inverse, and it's part of the process of finding the inverse of a matrix, but the determinant of a matrix actually tells us some important information as well. So it's really useful that we're able to calculate this before we calculate an inverse. The determinant of a matrix will be a number, and it can be positive, negative, or 0. Now, in the further maths course, you only ever have to manually, so without a calculator, determine the inverse of a 2 by 2 matrix. So if it's 3 by 3 or bigger, you'll always be able to use your calculator, but there will be some questions where you'll need to know how to find the inverse of a 2 by 2 matrix by hand. And the rule is that if our original matrix A was had the elements A, B, C, D, then the determinant of matrix A, which can be written a couple of different ways here, sometimes with these vertical lines or sometimes with det A, is calculated by, and it's really like this, you take the leading diagonals, the A and the D, and you multiply them together, right? And then you subtract the other two diagonals as a product as well. So it's A times D minus B times C. On your calculator, and you can see a screenshot there, you can also do this, and again, this is handy for the bigger matrices, by going action, matrix, calculation, and then DET. Right, and you can see an example of how that's typed in there to give you the determinant. So, in example 3, which is really example 2, we're going to find the determinants by hand and just get used to this sort of multiplication. So with the first one, you've got 2 times 5, so we could say det A equals 2 times 5 minus, and then it's the product of the other diagonals, so minus 3 times 3. Now you don't have to write brackets here because multiplication gets done before subtraction, but some people like to put brackets just to kind of really emphasize that you're doing the product first and then you're subtracting. So it's 10 take 9, which of course is equal to 1. All right, so the determinant of A is equal to 1. The determinant of B, same thing, so 2 by 3, 2 times 3 I should say, minus 2 times 3 again, with or without the brackets. All right, so that'll give me 6, take away 6, which is actually 0, so the determinant of B is 0. And the determinant of C, yeah, you get the hang of it, right? 2 times 3, take away 2 times 4, which is 6, take away 8, which is negative 2. All right, the question did also tell us to do it on the calculator as well, so just to run through that really quickly. So hopefully you can see my calculator there nice and clearly. So it's action, matrix, calculation, and then DET. All right, so thankfully they're all pretty straightforward to follow, and then we just need to remember how to input a matrix. So keyboard math 2, it's a 2 by 2 matrix that we're putting in for these questions. So the first one we had 2, 3, 3, 5, and you'll see the calculator is just going to churn out the determinant straight away. I'm just going to get lazy and copy that down to check our answer for B. Yep, we were right. And lastly, to check the answer for the determinant of C. And there we go. So nice and quick when you can use the calculator. All right, moving through. Lots to get through in this section. Okay, here we go. So we've talked about the identity matrix and we've talked about the determinant of a matrix. Now we're finally at the point where we can work out the inverse of a matrix, which is what we've been building towards. So the inverse of a 2 by 2 matrix, and this is important, again, like the determinant, you'll only ever have to know how to manually determine the inverse of a 2 by 2 matrix. If it's bigger, you'll be able to use your calculator. The rule here is that if we're trying to find the inverse of matrix A, that's just A, B, C, D, if that's our matrix that we're finding the inverse of, the inverse will be equal to 1 divided by the determinant of A. So you can see that it's going to be useful to calculate the determinant first. So 1 divided by the determinant goes in front as a scalar, as a number in front of our matrix. And then if you look at what's happened with the elements in the matrix here, you can see that the leading diagonals, A and D, have just switched places, right? So these two things swap, okay? The other elements, B and C, stay in the same place, but their sign changes. They become negative, right? So we get negative B instead of positive B and negative C instead of positive C. So the leading diagonals switch places. The other two elements stay where they are, but their sign changes, okay? And this is a really important note here. If the determinant is equal to 0, then the inverse matrix is undefined. And that's because if you've got 1 divided by 0 anywhere in a mathematical sum, you can't do it. It's not defined. It really is like it equals infinity, but infinity is not a number that you can define. So if the determinant of A is equal to 0, then the inverse of A is undefined or doesn't exist, okay? In your calculator, to find the inverse matrix, it's really simple actually. You just type the matrix in and then push to the power of -1. Right, so there's not even any menu buttons. You just type the matrix and then power of -1 and you'll get the inverse straight away. So that's pretty handy. Okay, let's go through example 4 here. And we're going to practice finding the inverse of this matrix by hand, but then we'll check our answer using our calculator. So the first thing to do when you're finding the inverse of a 2 by 2 matrix is actually to get the determinant. So I'm going to write that first. The determinant of C is equal to, for this one, it's 2 by 3 take away 2 by 4. All right, again, with or without the brackets. If it helps you can put them there. And we get 6 take away 8, which is -2. So the determinant of C is -2. And then we can say that, I'll leave that sort of separate, C inverse will equal, so remember it's using the formula, 1 over the determinant, so 1 over -2 times, and what happens inside our matrix is the leading diagonals, so the 2 and the 3 here, will switch places. So I'm going to fill those in first. The other two diagonals, 2 and 4, stay in the same position, but their sign changes. So +2 becomes -2, and +4 becomes -4. Right, now it is okay to leave your answer like that, okay, and it's completely acceptable, but it's also possible that we can write, so I'm going to say or, because I can write it either way, we can actually multiply that -1/2 into each of the elements. Remember, when you multiply by a scalar, you just multiply all the elements inside the matrix. So we could also make this -3 over 2, +2, because -1/2 times -4 would give us +2. -1/2 times -2 would give us +1, and -1/2 times +2 would actually give us -1. Right, now you can give your answer either way, but be mindful that when you're doing things like multiple choice questions, you might have to recognize that that answer is the same as that answer or vice versa. Okay, so it's important to understand both ways. Just quickly as well, we'll go through this one on the calculator just to show that it is quite straightforward. In fact, this matrix that we're doing here was the same one from the previous example, so I'm going to get super lazy. I'm just going to copy the matrix down and then put to the power of -1. And there's our inverse matrix. Now it looks, I'm in decimal mode here, so you can see that instead of getting 3 over 2, I've got 1.5, but it's the same matrix. All right, pushing on through these last couple, we've got example 5. looks a little different. We're given a matrix E and it says to explain using an appropriate calculation why E inverse is undefined. Now remember that we said before that if the determinant is equal to 0, that's when the inverse matrix is undefined. So there's a good chance here that the reason this will be undefined is because we're going to get a determinant of 0. But if we're trying to explain that, we need to show the calculation. So we can say, let's work out the determinant of E, and it is -3 times 6. Again, with or without brackets, so -3 times 6, take away -9 times 2. All right, now obviously at this point you can put that into your calculator, but if you want to do it manually, it's going to be -18 minus -18, which really equals -18 plus 18, which is 0. And therefore, the reason this is undefined is because the determinant of the matrix is 0, and that's what happens when the determinant of the matrix is 0. So we're going to say, therefore, E inverse is undefined as determinant of E equals 0. Okay, so we've explained using an appropriate calculation, and that calculation was to find the determinant. All right, lucky last here, this exam question. We've got a matrix A with the following elements, but one of them is missing. We've got this K, and it says that A is equal to the inverse of A for a particular value of K. Now, there's a couple of ways we could try to tackle this one, but what we're essentially being asked to do in this question is to try to get this matrix so that the inverse and the original will be the same thing. So, well, let's try it if we were to think about this maybe without a calculator and try to work out what the inverse would look like. The inverse of A would be, remember, it's 1 over the determinant. Now the determinant of this matrix would be, actually I'll write this separately. Determinant of A would equal -3 times 3, so -9, take away -4 times K. So take away -4K would actually be plus 4K. Okay, so we've got -9 plus 4K times, and remember what happens with the elements, we switch the places of these two, so -3, +3, and the signs change for these two, so we'd get +4 and -K. Right, now if we want this matrix, this whole thing here, to equal what we had when we started with, because that's the idea of the question, that A is equal to its inverse, well, you can kind of just look at all the elements here and see that what we really need is this determinant. The determinant here needs to equal -1, because if I were to multiply all these numbers by -1, I'm going to get back to what I started with. So we could say we want 1 over -9 plus 4K to equal -1. And my working might be a little bit hard to follow here. So this is the key idea. And we could try to solve that for K manually, but I reckon let's just chuck that into our calculator. And let's say we're going to do, let me see if I can get both of them in the screen there. Yep. So anytime you're trying to find an unknown that's sort of buried somewhere in an equation, go to solve. So we've got 1 over -9 plus, now you can go to the keyboard and use K. I'm just going to use X because the calculator, whoops, that's wrong. There we go. Calculator always tries to solve for X. So like I said, you can bring up K in the keyboard, but I'm just going to use X. And we get X equals 2. We're going to hope that's one of our options. Yes, it is. So we're going to be happy that the answer there is that K is equal to 2. All right, that's a pretty tricky exam question. So it might be worth actually looking at this exam question again after you've done the exercise on inverses, once you've had a bit of practice with it. But I hope that gives you an idea, a pretty long video I know, of finding the, or knowing what the identity matrix is, being able to find the determinant of a matrix, and also being able to find the inverse of the matrix. So have fun with exercise 12A and get in touch with your teachers if you need any help. Cheers, guys.